Yeah. So the next program we will be seeing is subtraction of two 8-bit numbers using the same processor 8080. So first we'll see what all we need to do. How to perform subtraction, binary subtraction. So let us perform the subtraction 6 minus 3 in binary form. So how are we supposed to do this? What is the binary equivalent of 6? 0, 1, 1, 0. Okay. And the binary equivalent of 3 is 0, 0, 1, 1. So 6 minus 3 would be 3, which is nothing but 0 minus 0 would be, we move on to the LSB position, and 0 minus 1 would be 1, and here this 1 is being borrowed over by this 0, so here it will be 0. So this 1 will be borrowed over by this 0 to become 1, 0. So 1, 0 minus 1 is 1. Now 0 minus 0 is 0, and 0 minus 0 is 0 as well. So the result will be 0, 0, 1, 1. So this is the case of a large number minus small number subtraction. So what if it is 3 minus 6? In that case, it will be 0, 0, 1, 1 minus 0, 1, 1, 0. In this case, it's a small number minus large number. So you need to complement the larger number and add it to the smaller number. So 0, 1, 1, 0 would be the 2's complement of 0, 1, 1, 0 would be 1, 0, 1, 0, 0, 1, 1, 0, 1, 0. So 2's complement of 6 would be 1, 0, 1, 0. So add it to 3, that would be 1, 1 and 0, 1. So this would be the answer. Now complement this answer, 2's complement this answer, that would be 0, 0, 1, 0. So that would be 0, 0, 1, 1. And just add a negative sign before it. So this would be your answer. So this negative sign would be a sign bit, so it can be minus would be a 1 bit, so it would be 1. So how are we supposed to perform this subtraction in a processor? So for that we need is first operand, that is 6 in this case, second operand, that is 3 here, and yeah, and we need to perform the subtraction, and we need to check for borrow. If borrow does exist at the MSB bit, then we need to complement the result and put an opposite sign for whatever result we get. So we'll see how we are just using the instruction set of 8085 to do this particular program. So the first instruction here is MVA C, 00. So what does this do here? It clears the C register so that it can store the borrow value. Next one is you're getting the first operand from the address line 4150 to the accumulator. Now the first operand is loaded from accumulator to the B register. The next thing you're supposed to do is get the second operand. That is, you're getting the second operand from this particular address line to the accumulator. Now, since you got both the operands, the next operation to be performed is subtraction. So this instruction again does is A minus B is equal to B, A. So what it will do is it will subtract the B register contents from the accumulator and store the difference in the accumulator. So jump on no carry. How does carry exist in a subtraction operation? Carry is nothing but borrow here. So if borrow does exist, it executes these three instructions. So what does these three instructions do? This particular instruction is to store the borrow in C register. This is, if borrow does exist at the MSB bit, then complement the result. As I told you here, result difference will be stored in the accumulator. So complement here. CMA would take the 1's complement of the accumulator value. So in order to take 2's complement, increment the accumulator value by 1. That would yield you 2's complement. The next thing you are supposed to do is store the difference in an address location. Here it is 4152H. Next thing is store the borrow value in accumulator, and from accumulator move it to a corresponding memory location, which is 4153H. Now we have stored the borrow and the difference value in memory location. So the next thing we need to do is halt the program, HLT. As you can see here, after halting the program, we need to clear the next address location in order to avoid the program execution to go any further. So we'll see a step-by-step execution here. So So first operand we have received, the second as well. Now subtraction is being performed and it's checking for borrow. As there is no borrow in this case, we are directly moving on to part 2 and storing the difference and the carry value, that is the borrow here, in the memory locations, and we are terminating the program. So we'll just move on to memory location 4150 to check what input there was. 4150 and 4160. So in 4150 we had given 08. In 4151 it was the second operand with 08 as well. And in 4152 it's 00 because 8, the same number when you subtract, we get difference is 0. And there's no carry, so that's 0 as well. What if we change this number? We give 06 and 03 here. So that would be 06 and 03, and now I'm giving my start address as 0000 and my end address as 0013, and we refresh, and again I do a step-by-step execution now. Yeah, so here 6 we have got, here 3. Now subtraction is being performed and we are storing the result. Since it's a large number and a small number, no need to complement the difference value. Now we go to the memory location 4152 50 and 4155 to check what the difference and the carry are, as it is 6 and 8 here. So 6 minus 8. 6 minus 8 would be 8 minus 6 would be 2. So that is answer here 2. And the carry here is 0. I'm sorry I had to 3 there, but this particular thing. Yeah, so we'll see about 3 here now. What if we give 0, 8 here and 0, 0, 8 and 0, 6 here? Now we'll see. 0, 6. Yeah. And I give an enter. Now move on to the memory location 0, 0, 0, 0 to 0, 0, 1. Remember one point that this is assembly language program. So I am giving the starting address as 4 zeros and the end address as 0013. Here the user defined location is 4 zeros to 1000. So, but in a processor, the user defined memory location would be 4100 to 41FL. So that is why you are supposed to do your entire coding process. So now I again do a step-by-step execution here. We get 6, then 8, then 6, and then yeah. In this case, it's a small number minus large number. So these 3 instructions are being executed. Then we are storing the difference in the borrow value and then terminating the program. Now we'll just go to the memory location 4150 to 4155. Check what inputs and outputs we have received. So 4150 is 08. This being moved to B register. Then 4151 is accumulated value, which is 06. So A minus B is 6 minus 8. That is small number minus large number. In this case, 4152 would be 02 and 4153 would be 01. This 01 is borrow value here. It's nothing but this particular MSB bit that you are seeing here. This one. That will be the borrow value here, 4153. So that is about subtraction here.